For this question, we want to determine the real solutions to the system of nonlinear equations. Our system of nonlinear equations is y equals x squared minus 9x plus 1 and y equals negative x squared minus 5x plus 17. Now, in this system, we can solve it with either substitution or elimination. And we already have both of our equations solved for y, so this really lends itself to the substitution method. So we're going to take this other side of the equation, x squared minus 9x plus 1, and we're substituting that in for y because this equation equals y. And that's going to give me the statement x squared minus 9x plus 1 equals negative x squared minus 5x plus 17. This is an equation with only one variable x, so I'll be able to solve this. I'm going to add x squared to both sides. I'm going to add 5x to both sides and subtract 17 on both sides, so I move all the terms to the same side. That's how we typically handle quadratic equations. X squared plus x squared is 2x squared. Negative 9x plus 5x is minus 4x. And 1 minus 17 is negative 16. I'm going to solve this quadratic by factoring, starting with factoring the greatest common factor of 2. Factor that common 2 out, and we're left with x squared minus 2x minus 8 equals 0. Then I'm going to try to continue to factor this quadratic. X times x is x squared. Factors of 8 could be 1 and 8 or 2 and 4. I'll use 2 and 4, putting a minus on the 4 and a plus on the 2, because 2 times negative 4 is negative 8. 2 plus negative 4 is that middle coefficient of negative 2. Now that I've factored it, I'm going to use the zero product property and set each factor equal to 0. To get x equals negative 2 and x equals 4. Now, solutions to systems are typically ordered pairs, and we have x coordinates for these two sets of ordered pairs, and I need to find the y coordinate. So I'll use that first equation, y equals x squared minus 9x plus 1. With x equal to negative 2 to find the y coordinate. That's y equals negative 2 squared minus 9 times negative 2 plus 1. Negative 2 squared is 4. 9 times 2 is 18. 18 plus 4 plus 1, that would be 23. So we have the ordered pair negative 2, 23 as a solution to this system. And then I'll find the other ordered pair, y equals x squared minus 9x plus 1. We have x equals 4. That means y equals 4 squared minus 9 times 4 plus 1. 4 squared is 16. 9 times 4 is 36. 16 minus 36 would be a negative 20 plus 1, that's negative 19. And we have the ordered pair 4, negative 19 as the other solution. So we have solutions of negative 2, 23, 4, and negative 19 for this system of nonlinear equations. For this question, we want to use either substitution or elimination to solve this system of equations. Our system is y equals 5/3 x minus 2 and negative 10x plus 6y equals negative 12. Now, the directions give us the choice of solving with the substitution method or the elimination method. As I'm looking at this problem, I think I would choose the substitution method because one of my equations has the y equals. So I'm going to take 5/3 x minus 2 and substitute that into y in the other equation because this equals y. And that gives me negative 10x plus 6 times 5/3 x minus 2 equals negative 12. Now I have an equation that only has one variable, and I'll use the distributive property. And when I distribute, I would have negative 10x plus 30 over 3x minus 12 equals negative 12. 30 over 3 is 10. We have negative 10x plus 10x. Minus 12 equals negative 12. That negative 10x and positive 10x will cancel each other out. And what we have here is a special case of our systems of equations in that we're intending to get down to one variable within our equation, but as we did that, all of the variables ended up going away, leaving us with this final statement here of negative 12 equals 12. So that means that this system is one of our special cases. What I mean by that, if we think about this graphically, a solution to this system is an intersection point. So most linear equations will intersect in a single point. However, we have a couple special cases where we could have two lines that are parallel to each other and have no intersection point, or we could have two lines that are actually right on top of each other. In that case, you have infinite number of intersection points, all of them being on top of that line. So whenever all of the variables cancel out, like it did in this problem, we know that our system is in one of these two states where we have parallel lines or two lines that are right on top of each other. And this final statement here is going to indicate to us which one of those special cases. So because our final statement is a true statement, negative 12 does equal negative 12. That is a true statement. We know that we're in this case right here where the two lines are right on top of each other. If you ended up with a false statement would indicate that your two lines are parallel and never intersect each other. So when we're in this case, where the two lines are on top of each other, we have infinite ordered pairs that are solutions, but they are restricted to only the ordered pairs that are on this line. So we need a way to indicate that. So we're going to have some ordered pairs. Those ordered pairs will be x and y values. And those x and y values, you can use this equation here to reduce down to, instead of two variables, instead of x and y, we'll reduce it down to just x. Now I did that because y was already solved for, so I would do 5/3 x minus 2 here. And this is the format for the ordered pairs that will satisfy both of these equations. These are ordered pairs that are on each of those lines. Now you could also do this in terms of y as well, but I would need to rearrange one of these equations to solve for x. So if I wanted to do that, I would take the equation negative 10x plus 6y equals negative 12. Solve for x, I would subtract 6y. That's negative 10x equals negative 6y minus 12. Divide by negative 10. To get x equals, I'll reduce that 6 over 10. Both of them are even, so that becomes 3 over 5y. And that 12 over 10, both of them are even, so 2 goes into 12 6 times, 2 goes into 10 5 times. So we could write our ordered pair xy as 3/5 y plus 6/5, comma, y. So that would be it in terms of the variable y. So our solution to this system of equations are all ordered pairs of this format or all ordered pairs of this format. On this question, we want to determine the real solutions to the system of nonlinear equations. My system is x squared plus y squared equals 1, x squared plus y plus 1 squared equals 4. As I look at this set of equations, each equation follows the format of a circle. So the standard form of a circle is x minus h squared plus y minus k squared equals r squared. So that first equation is a circle with center 0, 0 with a radius of 1. And the second equation is also a circle with center of 0, negative 1 with a radius of 2. So I can do a really quick sketch of this to see how many solutions I'm going to get out of this. So a circle centered at 0, 0 with radius 1 would be just a small little circle like this. And if the circle is centered at 0, negative 1 with a radius of 2, so I'm going to draw it in a different color. So there's my center at 0, negative 1 with radius 2, so I go 2 up, 2 down, 2 right, and 2 left. I would get a circle that looks like this. And it looks like, to me, I can see just one intersection point there at the ordered pair, 0, 1. So I think that's going to be my solution, but I'm going to solve this algebraically instead of graphically. And if I solve this algebraically, I'm noticing here that I have an x squared in both terms. So I'd like to use the elimination method and eliminate that variable of x squared. So to do that, I would multiply a negative onto, let's say, the first equation and leave the second equation exactly the same. I'm going to add those equations together. And when I add those equations together, like I planned, the x's eliminate, and I'm left with y plus 1 squared minus y squared equals 3. Negative 1 plus 4 is 3. And I want to solve this equation, so I've got to multiply this out. This is y plus 1 times y plus 1 minus y squared equals 3. If I multiply that out, I'll have y squared plus y plus 1 minus y squared equals 3. The y squareds cancel each other out. The y's combine to be like terms. 2y plus 1 equals 3. I'll subtract 1 on both sides, giving me 2y equals 2. Divide both sides by 2 to get y equals 1. And that gives me the y coordinate of my solution. I need to get the x coordinate. I can do that by substituting. So I'll take my equation x squared plus y squared equals 1. Let's substitute a y equals 1. That's x squared plus 1 squared equals 1. X squared plus 1 equals 1. Subtracting 1 to get x squared equals 0. And if I square root both sides, I will get x equals 0. So my ordered pair solution is 0, 1. Thank you for checking out my videos. Have a great day.